Numpy is the core library for scientific computing in Python. It provides a high-performance multidimensional array object and tools for working with these arrays. A numpy array is a grid of values, all of the same type, and is indexed by a tuple of non-negative integer. The number of the dimension is the rank of the array. The shape of the array is a tuple of integers given the size of the array along each dimension. So let us go through a few examples for us to understand more about the NumPy. So first of all, let's import the NumPy as NP, and then we can actually assign a tuple or a list in order for us to create a array object. So here we have the array from a tuple. So that is array np.array is the assignment of or you can say this is a conversion which converts this tuple into an array. So this is the array tuple, and then this is the list. So let me print this out. So I should show the tuple first. So you can see that there's no difference between this array object. Either passing a tuple or passing a list, that should be fine. Similarly, we can just create a 2D array by stacking few more rows. Say, for example, we have 1, 2, 3 in the first row, and 4, 6 in second row, last row, 7, 9, and here we have a 2D array. In order for us to know to have more details about an array, we can use some built-in function by the NumPy. Say, for example, we can have the dimension and have the shape. We can also have the size, and can also have the for example, we would like to know what are the types of this array. So ndim just return you the number of dimension, and shape just return you the shape of the array, and size just calculates or return the total number of elements that inside this array. And this types function just return you the class of this array, which is a ND array. We can also use index and slice to extract the required elements. So for example, we just get the first element from this array list, and then by using the indexing, and then we can also use slice functions to get to extract the data as well. Here we extract all the rows, and then for the second and the third column. It's a typo. So the 0, 0, it return you the 1, and then this one just get all the rows, and then the second and third column. There are many ways for you to create an arrays to fit your needs. say for example, and have a 0, 0 array. Say for example, we want to have a 3 by 3 matrix that contains zeros. So we can just call this function np.zeros and then provide the size of these, the size of the array that you would like to have. So you can see we have a 3 times 3 array that contains all zeros. Similarly, we can just have a change it to 1, and then we can use the numpy.ones functions to create a 3 by 3 matrix that contains ones. Instead of passing a specific size into these numpy.one functions, we can also use the shape of an array to create the same size or same shape that contain the ones. We can also assign random values in a given shape. Just change it to these ones to random.random. And then the shape, we just say, for example, 3 by 3. So right now we can have a random value between 0 and 1 that is assigned in a 3 by 3 array. Dot random function right here returns a random value in a given shape. However, we can also change it to random wen.n, which will return a sample from the standard normal distribution in a given shape. And then the given shape is 3 times 3 right here. So this is the result. We can also change it to random integer. And then in order for us to return a random integers from low to high in a given shape. So here, say for example, the low is 0, and then the high is equals to 3, and then the size is equals to, for example, the shapes of the leads. Here, the low is an inclusive. That means it will include the 0. And high is exclusive. That means it will exclude the 3. That means because this is an integer, that means the random integer will only generate up to 2 right here. So here is the result. We can also create a sequence of integer by using a range. So np.arrange. So say for example, we want to generate a sequence of integer from 0 to 20, and then the step is 2. So this is the sequence from 0 to 20. 20 here is excluded. We also can use the line space functions to create similar results. In a line space function, to specify the this is the starting value, this is the end value, and then we just specify how many equally spaced in between these two values that we need to create. So right now you can see that we have a similar results by assigning the space in between these two values. We can also reshape our finding. Say for example, we want to reshape the array, range array here to, say for example, because we have 10 elements here, we just reshape it to 5. That means we have 2 row and 5 column in a newly created array. So right now you can see that the original array is reshaped into a 2 times 5 array. Instead of a reshape, we can also uh, flatten the array. Flatten means that we are going to create a 1D array. So we just flatten this array back to a 1D array. So this is how we create an array. So let me show you how we can perform some simple mathematics function. So say for example, we have this log array. It's called. And then say for example, we want to add 1 to all of the elements in this array, and this is -1. And then say for example, we can also times 2 and then divide it by 2. And also our can transpose the array. So here are the results. Say for example, we just add 1 to the array, and so you can see that the element-wise computation has been done. This is what we call broadcasting. So we also just use the -1 to you just -1 for the array, and then we also multiply by the array by 2, divide the array by 2, and then power the array by 2, and then also just transpose the array by using the doc_t. So just like what I've mentioned, this array, the array is element-wise, or similarly, the array times the arrays is element-wise. So these two results are the same. So in order for us to have the dot product, so we need to use np dot and then just provide the 2 arguments into this dot function. So you can see that right now we have the dot product between these 2 arrays. Similarly, we can calculate the maximum. We can also get the minimum and also get the sum, so and so. Because this just sum up all of the values. Oh, sorry. I should say because this is a maximum in this 3 by 3 array. So say, for example, sometime we might want to um, get the row, get the maximum for each of the row. So we just provide an access value to it. And here, similarly, we can just change the access to 1 in order for us to get the maximum value for each of the column. So here are the results. We can do the same for mean and sum, but I'm not going to show here. We also can have can use the sine function, cosine function in the NumPy. And say, for example, we use the NumPy dot pi to call out the pi value, and then we use the NumPy dot sine to calculate the sine pi value. So similarly, we can do by replacing the sine by sine function. Similarly, we can also use an exponential function. For example, we can exponential 2, and then we can use the natural log as well. Exponential function, we just natural log it back. We can also have the square root function under the NumPy. So here are the results. So 0 for the sine function, and then -1 for the cosine functions, and then this 7.39 for the exponential functions, and then we just exponential, and then we just log it back, so we get back the 2, and then square root 4, so that comes out the 2. We can also have a short function. Say, for example, we just change some value in order for you to show results in the after the sorting. Say, for example, have this array just np dot short array assets go to none. So this will give you the results of 1D array for sorting the number from the smallest to the largest. However, sometimes we want to keep the matrix just sort by the column element sorting by provide the access equals to 0, and similarly can just provide 1 for a row element sorting. So here are the results. We can also use Boolean functions in the NumPy array. So for example, we just need the elements that is larger than 2. So this is the Boolean functions. So you can see that because these elements right here is less than 2, so this is give you a false. Because this element is less than 2, so this will give you a false as well. And we can also assign this Boolean into this array, and then just will return you a 1D array that has the numbers or elements that is larger than 2. So in order for us to keep this shape, we can use a where function. Here we just provide the logic that is the array has to be larger than the elements in the array has to be larger than 2. If that is correct, we put it back the array value. If that is not correct, we give it a new value 0. So here you can see that because this is false, so we just give it a 0. Just give it a 0. The other we just keep the original value. So that's all, and I hope you now have a better understanding of the NumPy. So thank you for watching.